Hello students, A2 Chemistry, chapter is Chemical Energetics, lecture number 4. In this lecture, we are going to learn how to write down thermochemical equations for the formation of ionic solution. Now you must remember, we are going to write down thermochemical equations for the formation of ionic solution using Hess's law. The type example that we will discuss, it is the solution formation for lithium chloride. Okay students, before we start the lecture, if you have not subscribed this channel, I invite you people to subscribe this channel and push the bell icon. Thank you. Okay, let's start. Now what you must remember, as you people know, according to Hess's law, every chemical process can be completed using direct path and indirect path. What you must remember, whenever we write down thermochemical equations for the formation of ionic solution, in the indirect path, there are two steps. This is the basic information that you must remember, that in the indirect path for the solution formation, there are always two steps. Second thing students, you must remember, there are two different styles by which you can write down thermochemical equations for the formation of ionic solution using Hess's law. Let's talk about first of all style A. In this style, we will take lithium chloride. Lithium chloride is a solid. We will add it in a water. Water as a solvent, it is written and spoken as aqua. When you will add lithium chloride solid in water, lithium chloride will dissolve in water, and lithium chloride from solid state, it will be converted into hydrated ionic form. Hydrated ionic lithium and chloride ions will be produced. Now this step by which we have produced the solution of lithium chloride, this step, it involves some enthalpy change, and that enthalpy change is known as standard enthalpy change of formation. Whenever we add any compound in water and its solution is produced, that enthalpy change is known as standard enthalpy change of solution. Now as I told you, in the indirect path there can be two different steps. So what can be the two different steps in this style? First step will be the bond breaking. We will break ionic lattice in the first step, and in the second step there will be bond formation between the gaseous ions and the water molecules. Let's see the first step. When we will break the bonds of ionic lattice, lithium chloride solid, it breaks, and lithium chloride solid, it breaks into its component gaseous ions. Gaseous ions, lithium ion and chloride ion will be produced. Now what this enthalpy change is known as? This enthalpy change, whenever a solid ionic lattice is broken, it is known as lattice enthalpy. You people know this equation can also be written in a reverse direction. If we will write down equation for bond breaking, lattice enthalpy is positive, and if this equation is written for the bond formation, lattice enthalpy would be negative. This difference you must remember in your mind. Now what will happen? These gaseous ions, in the next step, they will be surrounded and attracted by water molecules. When these gaseous ions, they will be surrounded and attracted by water molecules, bond formation will take place, and this bond formation will release energy. That energy, that enthalpy is known as hydration enthalpy. This is the hydration enthalpy of lithium ion into 1 plus hydration enthalpy of chloride ion into 1. So students, you can see this is one way of writing thermochemical equations for the formation of any ionic solution. In this style, what we have done, we have considered bond breaking of ionic lattice and bond formation of gaseous ions with water molecules. Now what is the second style that you must remember? In the second style, lithium chloride, again we will take the solid form of lithium chloride, we will add it in water, and lithium chloride, when it will be added in water, it will be converted into hydrated ions. It means we will produce the solution of lithium chloride. So that the enthalpy change of this step can be labeled as enthalpy change of solution. You cannot find any change in this step. But when you will write down two steps, in this case, in this second style, when you will write down thermochemical equations, in the second case, both the steps, they will represent bond formation. In style A, you can see one step is bond breaking, other is bond formation. But in this case, both bond formations can be shown. How is that? Look, if you take gaseous lithium and chloride ion, you can reverse the direction of the arrow. By combining gaseous lithium and chloride ion, we can get solid ionic lattice. So this is lattice enthalpy. But this time, in this case, lattice enthalpy will be exothermic because it involves bond formation. In the previous case, if you look at the same arrow, we have shown the arrow in the opposite direction. So that is why the lattice enthalpy in that case would be endothermic. In this case, the second step will remain unchanged when water molecule will surround these gaseous ions and hydrated lithium and chloride ion will be produced. The enthalpy change will also be unchanged. It will be the hydration enthalpy of lithium ion multiplied by 1 and hydration enthalpy of chloride ion multiplied by 1. Now both of these styles are in front of you, students, and what you can notice, there is only one reaction arrow that you must consider, that you can reverse. That reaction arrow is that of lattice enthalpy. So it means you can reverse the reaction arrow for lattice enthalpy. It depends on you. But if you are interested to show lattice enthalpy for bond breaking, in that case lattice enthalpy would be positive. If you want to show lattice enthalpy in terms of bond formation, then lattice enthalpy would be exothermic. Now, after that, you can apply Hess's law to get the formula for solving numerical problem. In that case, it is very simple. Simply you will apply the method which I told you in the previous lecture, how to identify the initial stage and the final stage. From the initial and final stage, you can identify the direct path and the resultant vector. Let's suppose for style A, this is the initial stage. Why this stage can be marked as initial stage? Because both the arrows, they are taking a start, their tails are touching this position. So this is the initial stage. What will be the final stage? Where we are having hydrated lithium and chloride ion. These are the these ions are representing the final stage. Now when you have marked the initial and final stage, you can easily identify that which arrow, which enthalpy change is representing the resultant vector, resultant arrow. So you can see resultant vector is always single vector, and in this case resultant vector is the standard enthalpy change of solution, standard enthalpy change of solution, and it would be taken equal to the sum of other two vectors. What is the sum of the other two vectors? It is equal to lattice enthalpy of lithium chloride plus hydration enthalpy of lithium ion plus hydration enthalpy of chloride ion. This is one way how you can write down thermochemical equations. You can find the formula to solve the numerical problem. The other way, in the second style, you can mark the initial stage and final stage. Initial stage in this second style will be the gaseous lithium and chloride ion. This part will represent the initial stage, and the final stage will remain unchanged, hydrated lithium and chloride ion. But in this case, what will be the resultant vector? The resultant arrow, the single arrow, that is the sum of the other two, it is the hydration enthalpy. So you can say in style B, the resultant vector will be the hydration enthalpy of lithium ion plus hydration enthalpy of chloride ion, and it is equal to sum of lattice enthalpy plus enthalpy change of solution. Now students, as far as chemistry is concerned, both these are correct method, correct ways to write down thermochemical equations for the formation of ionic solution. But remember, as far as A levels is concerned, in A2 we prefer to write down style B. So it is best you must remember the second method of writing thermochemical equations for the formation of ionic solution. In the second method, what you must remember, that in the indirect path there are two steps, but both the steps they are showing bond formation. One is the bond formation of ionic lattice, other is the bond formation of hydrated ions from the gaseous ions. So it is best for your A levels exam, you people must adopt style B. I hope you enjoyed the lecture. Thank you for your time. Bye for now.